Hello and welcome to this video. In this section, we'll be learning about the equation of a circle. Now, it's such an exciting topic, and I can't wait to show you. So, let's have a look at this derivation of the equation. Let's say we have put the circle here with the center at the origin. What is the definition of a circle? How would you describe to a child how to draw a circle? You would say, put a dot somewhere on your paper and make sure you draw this line to be equidistant from that center. You could say, let's pick a tie string to our pencil here, and let's just keep one end of the string at the center here, and make sure that all these points that are appearing as a red line here are equidistant from the center of the circle. Now, do you remember the distance formula? Equidistance means equal distance. And what was the distance formula? The First of all, the distance, we would in this case call it the radius, right? If you don't remember, just draw yourself some Pythagorean triangles, right angle triangles here, and we went through this calculation of the distance formula, and we said with Pythagorean theorem we know how to calculate the length of the hypotenuse of any right angle triangle. We would find the height, square it, and then we would find the length and square it, and then take the square root. Equation of a circle, it starts with the same notion, but actually we square both sides so that we have r squared written in simpler terms, so that we don't have to use a square root sign. Basically, what we're doing is we're fixing either this x here or this x as the center of the circle. Well, if we say this point is the center, and then this y value have to be the y coordinate of the center. The general case is that actually you write the center of the circle and you subtract the center of the circle from x's. So we are letting this y variable to change, this x and y to change and be the points on the circumference, and we are saying that this coordinate x1 comma y1 is the center of the circle, right? So these 2 points that I'm underlining, they stand for the coordinate of the center of the circle. They don't have to change. What's changing is this x variable and this y variable that doesn't have a subscript here. Now, of course, we square both sides, so then the square root disappears from the right and appears as a square on the left. So in general, if you had to write the equation of any circle here, you open a bracket and you write x minus the center, the coordinate for the center x value squared plus y as a variable minus the coordinate for the y coordinate of the center of the circle squared, and you write r square. If you do know the value for radius, you square it and you write it as a constant here. If you don't know and you have to figure it out, then you write your equation like so anyway, and then you will use it and you manipulate it to figure out the unknowns. All right, so we've been told what we figured out so far is that that's the equation of the circle. So in this case, we've been given an equation of a circle, and they are asking us what's the center and what's the radius of the circle. Well, center, don't forget that the minus sign belongs to the equation. So the center is 5 comma 7, and the radius is square root of 16, which is 4. It's clear that radius is already given to us. So there you go. It's like so. All right. So if you don't remember, we did discuss the translation effects. So anything that's inside of the bracket is saying to us that this coordinate at the origin, let do you remember the first example I used 0 and 0 here? This coordinate has moved 5 units to the right, and y coordinate has moved up by, sorry, yes, up by 7 units. I know it's y value, but it's because it's inside the bracket, we treating it as a translation effect that's opposite. So although it's minus 7, it's actually moved up 2.5 comma 7. And the center of the circle looks like so in this product. Okay, so let's look at another example. Here we've been asked to calculate what's the center of the circle. So you take this 3, you would simply flip the sign on it, and you take that negative 1 and you flip the sign on it. So negative 3 comma 1 is the center, and the radius is obviously 4. Now in this equation, once again, what's the radius and what's the center? The center is 5 over 2 comma negative 4, and this radius is the square root of 32. Now, if you don't know what's the square root of 32, you look for the largest square number that you divide by. Can we simplify this? Yes, we could have written this as 16 root 2, which is 4 lots of root 2. Alright, so next example. We've been told to show that this circle with this equation passes through this point. What it means is that show that one of this 5 comma minus 8 is a coordinate on the circumference of a circle. So it suffices to take this coordinate, substitute it into the left hand side. So it's better to write that we're just gonna start with the left hand side. We're not assuming that it's 20, we're just going to calculate it. So 5 minus 3 squared plus minus 8 plus 4 squared, and we're going to calculate it. 2 square here plus minus 4 square. Minus 4 square is the same as positive 4 square. So that's 4 plus 16, which is 20. Now here you write 20 is the right hand side of the equation. Therefore, it satisfies the equation, and we've proved that it is on the circle. Okay, so there's the working out one more time. So here the line AB is the diameter of circle, and A and B have such coordinates. We have been told to calculate the equation of the circle. So here's where you need to use your assumptions about perpendicular lines, midpoints, and whatnot. So the midpoint of these two coordinates will be the center of the circle. So let's find it. And once you do calculate it, all you have to do is actually find the distance between these two lines and half it to figure out the radius. And we write it like so. So first we're calculating the midpoint here. Minus 8 plus 4 is minus 4 divided by 2 is minus 2. So x coordinate of midpoint is minus 2, y coordinate is 5. Next is to calculate the distance between these 2 points, because remember the equation of the circle on the top right left corner is we figured out what these 2 coordinates need to be already. What we need to figure out next is what is the radius, so that we can put the square on it on the right side. So let's figure out the distance between point A and B. So the distance formula tells us this. So we're substituting x coordinates and y coordinates into it, and we'll figure out that the diameter is 40. So don't forget what you found here is the diameter. We need to half it. So when we half it, well, let's just focus here. Sorry, my bad. is we use the midpoint and one of these points to figure out the coordinates of the distance between the two lines. All right, there's two ways of doing this. Since we've already figured out the coordinate of the center of the circle, we actually don't need to figure out the diameter's length. We can go straight into the equation for the distance between the center of the circle and either end of the diameter points that we have. So doesn't matter which one you choose, you have to take one of them. So in our case, the -2 and 5 is the center of the circle, and we've taken 4 and 7 here. So then all you have to do is just use the distance formula, and you'll find out that is square root of 40. So square root of 40 is, in other words, square root of 4 times the square root of 10. That is 2 lots of square root of 10. There isn't any other further simplification for that. Now we need to put these to equation of the circle. So we write x minus the x minus minus 2 makes it a plus 2 squared plus open a bracket and write y minus 5 squared. Now squaring 2 root 10 is just going to give us 40 because we know this was r square will be 40, wasn't it? So actually we didn't need to simplify 2 root 10, but there you go. So that's the equation of the circle here. So that's written for you yet again. All right, in this next question, here is uh, a formula that you've been told this is the equation of a circle. Now, obviously, it doesn't look like what you expect it to be, but you do have to manipulate it to find the center and the radius. What do you do? Remember what I told you at the beginning with the prior knowledge test? You match these values that have x's with them, and how do you make it look like so? What do you think? What skill do you need? Huh? Have a guess. Of course, you need to complete the circle here. So you collect like terms here. Here we having x's of color coded it, so you realize that which values go with which ones. So x, we can rearrange it and write it the minus 14x next to the x square, and y square with the plus 16y. Now you can already send the 12 to the right hand side because, or leave it here for now, doesn't matter. Let's just focus how to complete the square. You're going to half this minus 14, which is a minus 7, and you're going to put it inside one square bracket, right? Like so. Make sure you write the negative 49 after it because what we had here, when you expand this bracket, you're going to have x squared minus 14x, and you're going to have an extra plus 49, which wasn't here, was it? So that's why we're subtracting 49 so that this would balance out with the blue above. Now doing the same thing for y, half of 16 is 8, and make sure you subtract 64 from that. And now you're combining the constants with each other to find the radius. So minus 49 and minus 64 and minus 12 add up to 125. So minus 125 goes to the right and becomes a positive number, which we would expect it to be. You would never have a negative number here because it has to be, this is r square. If you end up with r square as a negative value, you've made an error. Go check your working out. All right, so there you go. Now we can read the center of the circle from it. What's the center of the circle? Is 7 comma minus 8, and square root of 125 is the answer. Now square root of 125 is 5 root 5. All right, is the radius. Okay, so Good luck practicing from exercise 60. I'll see you in the next video.